Hey everyone, I'm excited to be here to discuss how you can speed up your software development with better insights and deeper diagnostics with new capabilities that have been jointly developed from the BigQuery and cloud logging teams. I'm Christopher Crosbie. I'm a product manager focused on advanced analytics here at Google Cloud. Later, I'll be joined by Charles from the cloud logging team. So, a fundamental requirement for enterprises wanting to transform themselves digitally is the need to store, manage, and analyze large quantities of operational data from a variety of sources. Logs are a critical data source for troubleshooting, machine learning, data analytics, security. So, while cloud logging today can already handle massive amounts of data, capturing petabytes with ease, many developers they still struggle to analyze this log data, and they're unable to find those symptoms in the log that lead to deeper diagnostics. And despite the large volumes of data, often they still find it hard to move from a retrospective log analysis to predictive insights and prevent issues before they happen. So, to help you achieve this next level of software development with better insight and deeper diagnostics, Charles and I are thrilled to announce Log Analytics, a new comprehensive, easy to use, cost effective, and performant tool within cloud logging that has the performance and power of BigQuery behind it. This capability should help you use your logging data for both better diagnostics as well as gaining more insight into your business. Now, with the companies I've worked with, I've seen several teams that rely on logging data. Yet, the majority of the users really struggle to analyze that high volume of messy that log data. And that leaves organizations with a lot of unrealized potential. So the new log analytics feature is directly targeted at those teams who are wrestling to extract insight that they need from that hard to analyze logging information. This is targeted at DevOps teams who want to improve system reliability, and they might be struggling with analyzing logs at large scale and want a centralized logging repository. Or IT teams that need insight into how to better manage their fleet, and they're struggling to analyze signals across multiple clouds or even data centers and look at the trends over historical amounts of time. Security teams that want to identify attacks and they want to start taking advantage of the latest and greatest machine learning and advanced analysis techniques to detect those threats. Or business users that want to make better decisions. Today, they struggle to get logs integrated with their visualization and analytic tools, and they struggle to combine their logs data and business data. Now, when I go and talk to these teams, it becomes pretty obvious what the source of their struggle is. What makes log analytics hard today is the complexity of the data systems that organizations need to run. So, most of you watching, you're probably familiar with a similar convoluted architecture at your own company, where possibly application logs they go into an Elastic index, and then that's where your application performance monitoring or Kibana dashboards are. But then you have lower level operating system network logs that flow into a proprietary security vendors database. Then, of course, there's other machine generated logs, like maybe from sensors or IoT data, and they get stored in a format that's optimized for time series analysis, which is then downsampled and moved into a data warehouse. And so there is a lot of overhead with all of this, and you definitely pay an additional tax for extracting and copying all that data around. So when I chat with the end users of these systems, they tell me that today's common architecture patterns it generates five critical issues that make this log analytics so hard. First is the latency issues. There's just a lot of additional hops, and that means data takes longer to get to different end systems. Two, there's no clear source of truth. Data transformations, they might happen in multiple places. That makes it a challenge to understand what's happened to the data. Three, moving to machine learning requires a lot of additional hoops. It is not trivial to just take a TensorFlow model or a notebook and put that on top of these various systems. Four, the reliance on multiple interfaces where the same users need to learn different systems, that just has a whole mess of different applications and tabs that users have to manually reconcile themselves. And even with all this user pain, the IT teams still have to manage a lot of high cost and management complexities of running all these different vendor databases and applications. When I ask customers what they want, It essentially boils down to having a separation between the log aggregation and the log applications. More of our tech savvy customers have already started to adopt BigQuery as their centralized log aggregation store for data collection, normalization, and storage management tasks like auditing and compliance. Now, here at Google, it does seem intuitive to us that customers are choosing BigQuery as their next generation log analysis platform. Dremel, which is the query engine that BigQuery is based on, that was originally designed and built for logs. And it's been used for over a decade for analyzing logs and creating sophisticated machine learning on those logs for some of Google's biggest applications: search, YouTube, Gmail. And so if I start to compare BigQuery against typical logging platforms that customers are using today, there's some clear advantages that I'm seeing. First is just the management. Today's logging platforms need more automation just due to the application shifting into ephemeral servers and microservice architectures. It's just becoming way too hard to keep up with all the various IT management tasks that are required for running the various logging backends. BigQuery, fully managed, serverless. Two, customers need data lake scalability. Logs, they are coming from all over now: on-prem, multiple clouds, Kubernetes, real-world IoT systems. What used to really be a telco scale for a lot of these security vendors that relied on logs data, it's pretty standard for your average enterprise now. And when it comes to security analysis, you need these logs in a centralized place. Threats are not system specific. If a hacker got into GCP, guess what? They probably got into AWS too. And you want to review and track that in one location. It's equally important to also have a full history of the logs. That's becoming more important. If you look at something like the recent SolarWinds attack, that went back over 9 months. It doesn't work anymore to just have 30 or 60 days worth of logs in your security database. You need something that can cost effectively and independently scale the storage and analysis like BigQuery can. And speaking of security, you know, the security posture that many of these legacy or on-prem log systems had, they relied on security controls, like maybe the network as a primary layer of protection. But now in our cross-cloud world, things like network perimeters are vanishing. And you mix that with tougher regulations like GDPR, you really need a backend now that can help you achieve a security posture that makes it easy to align to our digitalized world and that you can trust with your login information. Another big one that I'm really hearing from customers is the need for advanced analytics and custom ML. Customers are finding that these pre-canned outlier dashboards that their logs applications are coming with, they just don't cut it for the systems today. I was working with one enterprise who moved over their existing SIEM to GKE and almost instantly got 30,000 erroneous alerts. So customers have told me that they want to do their own analysis, develop their own algorithms that are designed for their architecture, their business. BigQuery is already being used by some of the largest security vendors out there to develop XDR platforms as an alternative to reactive approaches of the SIEM. And they're doing that with GCP AI capabilities like BQML and Vertex. Finally, there's just a lot of new use cases that customers want to use, that customers are realizing. Customers, they understand now that there's a lot of business value in joining all of this logging data to their business data, and then they want to share it with others. I'm working with an e-commerce company who's analyzing weblog data alongside their clickstream data to better understand how users interact with their site, and then they can offer them better product recommendations. And that's already led to increased sales for them. So having logs that can be easily analyzed and joined to the rest of your warehouse, that just opens up a whole new set of use cases like predicting customer behavior, optimizing online marketing campaigns, and maybe even understanding how employees engage with different software solutions in your organization. So to unlock these use cases and help customers better understand the logs data that they bring to BigQuery, we're enhancing support for log analytics with investments in 3 core areas: semi-structured data, search indexes, and time series analysis. These new features and functions are going to let you explore and analyze the wealth of logging data that you have alongside your business data. So with native JSON, there's going to be a new data type specific to JSON. And it's going to, on a load, shred that JSON document that can be unstructured, constantly changing, into a columnar store format so you can get the same performance and cost effectiveness that you've come to expect from any other structured data in BigQuery. Along with that, you're going to find additional JSON functions like a dot subscript notation to make it a lot easier to work with these JSON data sets. Second, the search indexes are going to provide text indexes that provide users the ability to run what I call needle in the haystack type queries on the log data. This is when you want to pinpoint a very specific data element. So let's say I want to find Chris Crosbie in a petabyte of logging data so I can delete him for GDPR reasons. This search index is going to let you do that, or find specific IP addresses or other specific data elements. Finally, coming soon is there's going to be also time series joins and data types. So we're going to support joining tables by arbitrary time windows. We sample that data, and you'll also be able to store time periods as opposed to just a point in time. So here at GCP, we're putting our money where our mouth is, and we're standing behind these features in our own logs applications. We are using these features as a base for our log analytics application from Cloud Logging. And so now I'm going to hand you over to Charles to tell you more about that.
Thanks, Chris. My name is Charles Baer. I'm a product manager in Cloud Logging, and Chris and I have been partnering on log analytics. The log analytics combines the purpose-built logging platform provided by Cloud Logging with BigQuery's powerful data analytics platform. And we built log analytics in Cloud Logging for 3 reasons. First, ad hoc log analysis, to empower users to answer sophisticated questions where ad hoc grouping can deliver useful insights. Or log aggregation, to answer the types of questions that require log aggregation over large data volumes, and to build a platform upon which both our users and our product can grow for the future. Now, Cloud Logging is uniquely positioned for log analytics. Cloud Logging provides an integrated logging solution, both for services that are running on top of GCP, as well as logs that are generated externally. This includes log collection, routing, storage, and analysis, all the things you need in a logging platform. So in Cloud Logging, log collection is really easy. Logs for services on Google Cloud are automatically collected, and it's easy to collect other infrastructure and application logs if you need to. And getting the right logs is easy, as it's a first critical step for the log analytics as well. The second thing is the logs router. It provides powerful routing capabilities. The built-in routing routes logs to Cloud Logging, other GCP services like Cloud Storage, and even to external third-party tools with integration through PubSub. Now for log analytics, the platform routes logs to BigQuery. The storage platform provides a scalable log management capabilities. These capabilities provide controls around what logs are stored, where they're stored, how long they're stored, and who can access them to meet your compliance requirements. For log analysis, this manages the storage and access in BigQuery. Now, Cloud Logging already provides several tools to analyze logs, each with special purposes. The Logs Explorer is a tool optimized for troubleshooting use cases, with great features like log streaming, a log resource explorer, and a histogram for visualization. We have error reporting, which helps users react to critical application errors through automated error grouping and notifications, and through log-based metrics, dashboards, and alerting, which all provide other ways to understand and make your logs actionable for operational use cases. Our new log analytics feature expands this toolset to include ad hoc log analysis capabilities. Taken together, Cloud Logging provides a powerful platform specifically designed for working with logs. So what is log analytics exactly? Log analytics extends the capabilities provided by Cloud Logging in several important ways. First, log analytics automatically stores logs in BigQuery with a simple configuration setting. With a checkbox, enable log analytics when you're creating a log bucket, you can use Cloud Logging's pipeline to make it easy to store those logs, which you can then analyze in log analytics. Second, we're excited for a new purpose-built log analytics UI, which provides access to the logs using SQL. Now, SQL is a well-known, widely used domain-specific language, has powerful aggregation capabilities, and of course, it's widely used in BigQuery. When you need to group by or sum or find a ratio, log analytics supports the same standard SQL functions provided by BigQuery. Now, the log analytics UI provides an optimized results experience designed specifically for working with unstructured log data. And you'll see more of this experience in the demo later. Third, logs included in log analytics are made available directly in BigQuery. If users need to join logs with another data source, they can run the same query in Log Analytics UI and the BigQuery UI and join that data with data already in BigQuery. So by making this log data available where users need it, Log Analytics can help remove data silos. So how can you benefit from these new capabilities? Log Analytics can help reduce the need to send logs to so many different systems to address the separate use cases. I'll cover 3 common use cases as examples. First is for the DevOps team. Resolving issues quickly is critical to maintaining system reliability, especially when user-facing services. Log Analytics helps here by helping users more quickly find patterns by correlating IDs across services so that you can reduce outages more quickly. Faster troubleshooting can also help improve the speed of software development by reducing time spent on debugging and therefore freeing up developer time. The second is security. Investigations are a critical part of understanding and remediating security threats. Log Analytics can help here by finding logs across large time ranges, which often means large data volumes. The third is IT operations. Managing a fleet of different services is a core part of IT operations, and it's important to understand the events and trends across the whole fleet. Log Analytics helps here by identifying patterns and the fleet performance over time. Now, there are many ways that Log Analytics can help enable business decisions, including analyzing business data reported in logs. And by unlocking valuable insights, Log Analytics brings new value to your logs. And now, since there's no better way to show off a new feature, let's see a demo. In this demo, I'll show you the new Log Analytics UI, an example of combining data stored in Log Analytics with other data in BigQuery. I'll highlight the capabilities offered by Log Analytics to address 2 use cases. One is the DevOps troubleshooting use case, and the other is a security use case. For the demo, I have instances of the Online Boutique, which is an open source microservices demo app, and it's deployed to 2 GKE clusters, which are generating logs, which are ingested into cloud logging using the out-of-the-box configuration. I've set up a logging sync to capture the logs and send them to Log Analytics enabled bucket and cloud logging. With a click of a checkbox, logs are available both in Log Analytics, in cloud logging, and in BigQuery. First, let's look at the Log Analytics UI, which is a new UI in cloud logging, optimized for viewing logging data. In the Log Analytics UI, use the same standard SQL that is available in BigQuery. SQL queries are used to view the log data and can range from simple or complex. There's a query builder here where you can enter SQL in a results viewer to view the query results. To start, let's take a look at the completed Kubernetes logs for the front-end service over the past hour. Once the query is valid, I can run the query. Now, the Log Analytics UI provides 2 specific optimizations that have been added to BigQuery and used by Log Analytics. The first is the JSON value function, which allows you to extract JSON data and compare it to strings, which is really useful and for queries like this, or when you want to look at the string results of data stored in JSON. And the second optimization is the JSON dot notation. Notice that the JSON payload dot message field is actually using the dot notation to refer to a field inside the JSON structure of a JSON payload. Both of these make it easier to work with JSON data. The results are displayed using a view optimized for working with log data. You can see that the JSON payload is actually stored as JSON data, which means that any JSON structured data can be stored in there without having to know or specify the schema upfront. In the Log Analytics UI, the JSON data is actually displayed using JSON preprint format to make it even easier to use. Now, by looking at some of these logs, I notice that there is a value inside these logs, which is the response took milliseconds, which is the time the request took to complete. So one of the things we can do is look at the min, max, and average values of that over time. These kind of queries can be very useful when troubleshooting. So let's take a look at what this would look like. There we go. Okay, so what we're doing here is we're extracting this field and we're casting it as an integer so we can do the sum. We're also taking the hour, and then what we're doing is we're grouping, looking at the minimum, the maximum, and the average value. Now what we notice by looking at the results here is that around hour 14, both the maximum as well as the average time increase substantially. So this gives me great insight during troubleshooting, and it can help me more quickly identify the signals, which can help me resolve issues more quickly. The log analytics provides the flexibility to look at individual logs, as you've seen, and run complex aggregations, which can help surface critical insights for the DevOps team when troubleshooting an issue. Now let's take a look at the security use case. Again, staying with the same scenario, the app deployed to GKE. This time, let's look at the security-related logs for application and infrastructure. We can do that by using a query like this. The main difference here is that we're looking at the proto-payload field here, and we're looking for audit logs. So why don't we run the query? Here's what the audit logs look like in Log Analytics. You can see that they are the record type within BigQuery, and you can see that there's a detailed structure of the audit log within the proto-payload field. There's a lot of information that's stored within an audit log, and it's actually displayed in the UI using the JSON preprint format to make it easier to work with. All of the fields that are actually stored as a record type are also displayed using the JSON data type to make it easier to work with. Again, what's more interesting is to look at the aggregations. So let's take a look at the audit logs grouped by the principal and the IP address fields, which are the users as well as the IP address from which those actions originated. Great. So now we can see both the email address and the IP address and the number of calls that have originated from both. Now, for security use cases, sometimes it's useful to search for a value in a log without knowing which specific field. The newly added search function in BigQuery allows you to do just that. The function searches across an entire table or set of columns to find a value. To demonstrate, let's pick an IP address and find all the audit logs associated with the IP across any field in the table. And we can do that by using the search function, specifying the table, as well as the IP address defined. So by using the search function, I've been able to find all of the records that are associated or include this particular IP address. This is extraordinarily useful for unstructured data that is stored in JSON and other fields. For example, it's not limited to IP address or just for audit logs, can be used generally across any of the fields within BigQuery. Now, one of the powerful features of Log Analytics is it also provides you with access to the same log data in BigQuery. While Log Analytics provides an optimized UI and one that will evolve to add more optimizations, having access to log data in BigQuery means that you can join the log data with other data in BigQuery. By clicking the Run in BigQuery link in Log Analytics, the same query is loaded in BigQuery, and running that will return the same results with the standard BigQuery formatting. You'll notice it's the same data, however, the results appear differently for the proto-payload format. Now in BigQuery, we can combine that IP address data that we looked up in the previous example with other data. As an example, I'll combine the IP address with a public data set and use the functions in BigQuery to produce a list of all the countries and the number of logs for each. I can do that with this query. Here we have the select statement, which will look at all of the audit logs over the past 30 days and select the IP addresses from them, as well as the count. And here we'll join that data with the public data set, as well as use the BigQuery IP functions to be able to get the country associated with each of those IPs. So by combining the audit log data with the geolocation public data set, I've been able to gain insight into the requests coming from different countries. Most of the requests have come from the United States, but I do see that other requests have originated from places outside the United States. This combination can provide powerful insights. So to recap, Log Analytics and Cloud Logging provides a powerful way to analyze your logs based on the power of BigQuery. The Log Analytics UI provides an optimized way to view and work with log data. And the log data stored in Log Analytics is made available directly in BigQuery for joining with other data. While we're excited about Log Analytics, we're already hard at work making it both easier to use and more powerful. To make it easier to use, we're working on adding a new visualization result type via charts so that users can more easily understand their query results. We're also working to simplify the user query experience. We know that not everybody's a SQL expert, which is why we're working to make it easier to gain the benefits of log analytics without becoming a SQL expert. We're also working to enable log analytics by default. This will make it easier for any users to access the advanced logging capabilities. Now, to make log analytics even more powerful tool, we're working on logging insights. Logging insights can surface data that you would otherwise have to search to find. By analyzing data proactively, log analytics can help uncover powerful insights, such as proactive recommendations. We're also working on to expand the scope to include other operational data. By combining logs data with other operational data, such as trace data, you can gain even more context for a more rich analysis. We're really excited about launching the log analytics feature today, and we're excited to see the powerful ways that you'll use these new capabilities. So on behalf of the whole cloud logging and BigQuery teams, thank you for watching. To learn more about log analytics and cloud logging, please visit our docs and sign up for the preview to get started.